Welcome. In this video, we'll demonstrate how to actually build a GFDT or histogram by hand. For this demonstration, I would encourage students who are in my class to make sure that you've downloaded the flowchart handout that is available on the course website in the module on organizing quantitative data. In addition, you can locate the physics final exam data set that we'll be using for this demonstration. If you are not in my class and you're just watching this video, the final exam data is actually shown in the video that you're about to see, and the steps of the algorithm to build the GFDT are spelled out in detail in the video, so you don't actually need the flowchart that I've made available to my students. So, the first thing I'd like you to do is to look at the physics final data set, and just looking at the numbers that are provided, see what information jumps out at you. What things do you notice about the data set? So I'll be quiet for a moment here while you can view the data, and then I'll encourage you to pause the video to take notes on what you observed, and then we'll resume and summarize from there. At this point, I'd encourage you to pause the video and reflect on what observations you noticed about the data. Now that you've had a chance to reflect on the data, a few things that people have noticed in the past are the following. So most people pick up right away that the range of the data is from 50.5, the minimum, to 95.5, the maximum. And another key feature that jumps out at a lot of people is that all of the data appears to end in a 0.0 or a 0.5, which seems to suggest that the discrete unit is probably 1/2. For example, however the points were scored on the test, it appears that partial credit may have been awarded in increments of 1/2 of a point. Now, with these three numbers, the minimum, the maximum, and the discrete unit, we can begin the process of building the GFDT. The algorithm that we're going to use follows the following 4 steps. First, we have to find the class width that is appropriate for our data. Second, we need to find the first lower class limit for the data set. Then we will list all of the classes. Those essentially are the bins or the buckets in which the data is going to be sorted. And then finally, we'll count the frequencies for each class. Again, we already have the quote-unquote ingredients for this recipe. We need the maximum, which is 95.5, the minimum, which is 50.5, and the apparent discrete unit, which is 0.5. At this point, we can now fill in the flowchart or go through the steps that are shown here. So the first thing we're going to do is find the range, or more appropriately what I refer to as the span of the range. That's the range that also accounts for the discrete unit of our data set. So again, using our maximum and minimum value, we find the range by subtracting the values. In this case, we get the value 45. Now again, the evident discrete unit that we seem to observe here was about 0.5, and if we add that to our range of 45, that gives us the span of the range. That's 45.5. Again, the span of the range is akin to when you're working with discrete data, you need to give yourself a little bit of extra room to sort of capture all the data. The analogy I like to use is that if you're reading pages 10 to 20, that is a distance of 10 pages, 20 minus 10, but if you're reading everything on page 10 all the way through everything on page 20, that's actually 11 pages that you're reading, and this is that same idea. Now we'll set aside the span of the range and move on to the next step to find the class width. With the span of the range, 45.5, we'll ask ourselves, how many desired classes do we want? Well, I'm going to go with the standard value, which is about 10, and we'll divide the span of the range by the number of classes, which gives us the value 4.55, and now we need to round this up or down to a quote-unquote nice number. Well, I think the nicest number that we could round to here would be 5, and I'm picking 5 because it's relatively easy to count by 5s. Now that we have our class width of 5, we'll go back and find the first lower class limit so we can start to build the GFDT. Using the minimum of 50.5 and the class width of 5, we divide to get the value 10.1. Now, if I round this number down to the number 10, I can multiply this by the class width of 5 to get 50, and that gives me the first multiple, which is less than or equal to the minimum of the value in the data set. Again, this is the multiple of the class width that is less than or equal to the minimum of our data set. And this is the point at which we want to start building our GFDT. So we start with the first lower class limit, and we'll add the class width to take us to 55. And then we'll continue this process, 60, 65, 70, 75, 80, 85, 90, 95, 100, until we reach the first lower class limit that is larger than the maximum of our data set. The maximum in this data set was 95.5, and 100 is above that value. So we actually do not need the value 100. So we'll list out all of the lower class limits, and from here, we'll now list all the upper class limits. So we want to note that we're not counting from 75 to 79 or 75 to 79.9. While those might be reasonable intervals for other type of discrete data, this data is counting by 0.5, so it would be better to write the interval as 75 to 79.5, as that actually captures, that gives us a bin in which every value that might be found in the data set can actually go into that bin. There are numbers 75.0 in the data set. There might be numbers 79.5 in the data set. Okay? If we had done 75 to 79, we would actually not have a bin for the number 79.5. And if we use the number 75 to 79.9, that suggests we could get a 79.9, but we kind of know from the data that that didn't actually happen. Now, there are a couple ways we could write these interval notations. So the first one is to actually use square brackets, where we would use a square bracket around the 50 and a square bracket around the 54.5, indicating those values are all included. Or we could also use a half closed, half open interval, where we use a square bracket for 50 and then a open parenthesis for the upper class boundary at 55, which is technically the next lower class limit. The next step is then to obtain the frequencies for each class, and this is done by actually going back to the original data, which I encourage you to do, and look to see how many values were there between 50 to 54.5. In this case, there were 6 values in that range, so we indicate the frequency here for that. And this then gives us the grouped frequency distribution table for our physics final exam data, the GFDT. I encourage you to convince yourself that these numbers are indeed correct. And then once you have the GFDT, we could build a histogram from this by just using the frequencies to build the bar chart. All right, I hope you found this demonstration useful.